So far, we've learned about exponent rules when we're multiplying, exponent rules when we're dividing, and then today we're going to be learning the last couple of rules, which are about zero exponents when the exponent is actually a zero, and then negative exponents when the exponent is a negative number. So the zero rule means that anytime you have any number, no matter what the base is, I'm just going to use the variable here for this example, any number a, and it's raised to the zero power like this, it always equals 1. If you have a graphic calculator and you wanted to just test it, you could put literally any number in for the base and raise it to the power of 0, and it equals 1. It works with variables. It works with regular numbers as well. If you have the entire thing, like maybe like x squared times y and all the stuff inside, if it's ever raised to the 0 power like that, if you ever see like this big long thing and in parentheses it has all this stuff on the inside and it's raised to the power of 0, you should be feeling really excited because there's nothing you have to do. It just equals 1. So this is an example with variables, and then an example with numbers could be like 2 to the power of 0, it equals 1. And if you ever have a negative number like negative 3 raised to the power of 0, that equals negative 1. The reason that this happens is because when you have positive exponents, that exponent tells you how many times the base number is going to be multiplied by itself. When you have negative exponents, is what we're learning next, it tells you how many times that number is being multiplied by itself in the denominator, which turns it into a fraction. And then when it's 0, it just equals 1. So it's like almost like it's opposites. The negative exponent rule means that whenever you have something like a to the negative b power, something like this, whenever you have a negative exponent, it's considered to not be simplified. So when I'm giving you these problems, and I say simplify this expression, you're going to want to put it in simplest form, which means you want to use the product rule or the quotient rule so that you only have one base number instead of a bunch of them. You also want to use the negative exponent rule. If you ever have negative exponents, you want to make sure that those go away. The negative exponent rule means that when you have a base number to a negative number as its exponent, it actually takes that number and turns it upside down into its reciprocal. In this case, this would turn into 1 over a to the power of b, like that. So every single number is essentially starting out as a fraction, but if there is no fraction to start out with, then you know that there is like an invisible 1 underneath of this. So when you have this negative exponent, what happens is the fraction that doesn't even look like a fraction right now flips upside down to be its reciprocal, and then you can turn the negative exponent number into a positive. For example, if you have something like 2 to the negative 3. And I said simplify this. Simplify means use exponent rules so that everything is in its simplest form, and negative exponents are not considered simplified. To use the negative exponent rule would mean to take this thing, 2 to the negative 3, and rewrite it so it turns into a positive exponent. You do that by taking this, turning it into a fraction, putting 1 on the top, since there is an invisible 1 on the bottom. We just don't usually write that when it's not needed. So you just flip it upside down, and instead of having 2 to the negative 3rd power, it then becomes 2 to the 3rd power, a positive 3 in the denominator. So 2 to the negative 3rd power is the same thing as 1 over 2 to the 3rd power. If I then said simplify, that's what you would do. And if I said evaluate, then you would evaluate this by saying, okay, 2 to the 3rd power is 8, so this equals 1/8. You can use your calculator for something like this, 2 to the negative 3rd. Like if you put in your calculator 2, the caret button, and then negative 3 and hit enter, it will show you the answer here. But it is something that you do want to know as well. So I'll show you what I mean by that when we do these practice problems below, how to use our calculator for these certain types. Because whenever you have plain numbers, you can use your calculator as an aid, but as soon as you have variables, you cannot. And then the negative power rule is honestly the same thing as the negative exponent rule. There's really no difference here in explanation, so I don't need to go over this. It's the same thing as this. I don't know why this is written twice. So same exact thing here. There's nothing new with that. So for A, B, C, and D, we are going to be simplifying these and evaluating them so that they are in numerical form. So 2 to the negative 4. I want to show you what this actually means because once we get to variables, you're not going to be able to use your calculator to help you that much. 2 to the negative 4. Since this is a negative exponent, I can use the negative exponent rule to simplify it because you can never have negative exponents as your final answer. It's not considered simplified. So the negative exponent rule says this thing does start out as a fraction. We don't usually put a 1 underneath of something that is just like a whole number or integer like this. We put 1 underneath of it. And then when we go to use the negative exponent rule, what ends up happening is that these things flip upside down to be the reciprocal. So this really equals 1 over 2 to the then positive 4th power. You take the negative 4, flip it, and turn it into positive 4, and then this is what this would equal. And then from here, you could simplify this by, we'll evaluate this by getting the final answer of 2 times 2 times 2 times 2, and 2 times 2 times 2 is 8 times 2 is 16, so this would equal altogether 1/16. Now that's how you would do it algebraically, and like I keep saying, you will need to do this with variables because your calculator can't help you with that part of it, but let me show you how you can use your calculator to help you with this part of it at least. So 2 to the negative 4 is what I'm going to show you first. Once this application opens. So to type this in our calculator, I will just first hit 2. Okay, so I'll first hit 2 and quit out of this. And then use this little caret button, which is right above the division sign. And then I would hit in the negative 4, hit enter. Whenever you use your graphing calculator, they're always going to give you the answer in decimal form like this. And in this section, I think that fractions are the best form. So not that it would be wrong if you put 0.0625, it's still right. But for this section, I prefer fractions. So let me show you how you change a decimal into a fraction in your graphing calculator. All you need to do after you get your answer in decimal form is hit this math button, which gives you a bunch of different options. And the first option that it's already on is fraction. If you hit enter, it'll make that answer that you just got and change it into a fraction. Hit enter again, and it gives you the answer in fraction form. So that's 1/16. So 2 to the negative 4 power is the same thing as 1 over 2 to the 4th power, which is the same thing as 1/16. Letter B can also be done in our calculator, but I do want to show you how to do this by hand. Whenever you have a negative exponent, the negative exponent rule takes whatever's happening and it's going to basically flip it upside down and then give everything the positive exponent. There's 2 ways to do letter B. So the first thing we could do here with this problem is what we learned yesterday, which was the quotient to a power rule. The quotient to a power rule says that if you ever have a fraction raised to a certain power, you would give both the numerator and denominator that power. This would turn into 4 to the negative 3 over 5 to the negative 3. And again, you could at this point put this in your calculator, hit enter, and get the numerical answer. But if I said simplify this, I don't necessarily mean give me the numerical answer. It means show me that you understand the exponent rules. Whenever you have negative exponents, what happens is wherever the current number is that has the negative exponent, it's going to go to the opposite location in fraction form. So since this is in the numerator, this is going to go to the denominator, and since 5 to the negative 3 is in the denominator, it's going to go in the numerator. So everything's going to flip upside down, and when it does flip upside down, it will turn into the positive version of those exponents. So 4 to the negative 3 over 5 to the negative 3 is equal to 5 to the 3 over 4 to the 3. It's a very interesting, weird concept, but that's math for you. So you just flip it upside down, you turn the negatives into positives, and then that's what that would equal. And then if I asked you to then get the numerical answer, you would use your calculator to help you with that. Just real quickly, why could we not use the quotient rule to simplify this further? Perfect. These bases, the 5 and 4, are not the same, so we couldn't simplify this further using any other rules. If I said simplify this using exponent rules, this would be your answer. And then if I said evaluate it, then what you would do is use your calculator. And you could do 5 to the 3rd power divided by, what was it, 4 to the 3rd power? 4 to the 3rd power. And then they will give you the answer in decimal form. Hit math, fraction, or math, enter, enter, and it'll give it to you in fraction form. This is 125 over 64. Now, I do want to tell you, though, that you could do this from the very beginning in your calculator, 4/5 to the -3. So if I go to my calculator, I have to use parentheses. If I do 4 divided by 5, like this, that means 4/5. I can raise this to the -3, hit enter, and it'll give me the answer automatically. Then to put it in fraction form, since you would never want to just answer this and leave that as your answer because it's possible that that doesn't end, that decimal keeps going, just hit math, enter, enter, and it'll put it into fraction form for you. All right, next one. Anytime you see a power of 0, you should be feeling really excited because that's just equal to 1. 25 to the 0 power just equals 1. You can verify that with your calculator. Any number raised to the power of 0, if it's a positive, will equal 1. So we could just verify 25 to the 0. It equals 1. And then letter D is a little bit weird because we have a negative fraction and we also have a negative exponent. So negative exponents are only attached to the base numbers. So 8 to the -2 is what we need to simplify. My answer will still be negative because this negative on the outside is just saying it's a negative number. So I know my answer is going to be negative, but what happens here is because this is a negative exponent, it's going to change locations. Right now it's in the denominator. It's going to move into the numerator. So the whole thing will move to the numerator, and the fraction basically flips upside down. This will then turn into 8 squared over 1. So whenever you have a negative exponent, it's just going to move everything around from where it currently is to the opposite. There's 2 locations. It's either in the numerator or in the denominator. Negative 8 squared, like this, will end up being 8 squared is 64, and negative of that will be negative 64 is the final answer. Okay. So there are a lot of examples here below, and some of them are a little bit difficult. So what I want you guys to do is try A, B, and C. And then we'll go over those, and then we'll do maybe one of the last 3 together, and then I'll have you guys try a couple on your own. So try just A, B, and C for now. Is this what these look like? Oh, wait, no, sorry. Sorry, I'm all mixed up. Try 1, 2, 3, and 4, sorry. Do these 4 problems here, you'll be fine with those. That's why I'm confused with the next part. So do 1, 2, 3, and 4. I'll give you a couple minutes, and then we'll go over them. All right, so number 1, 5 to the negative 2. To simplify this and make sure that the negative goes away, the negative exponent rule says that if you have any base and it's raised to a negative exponent, if it's currently in the numerator of a fraction, it goes into the denominator of the fraction and then gets the positive version of its negative exponent. And then if it was already in the denominator, then it moves into the numerator. So it's like pretty confusing. Right now, this is in the numerator of a fraction that we don't even see. If it's helpful for you, you can take everything that's not currently in fraction form and turn it into a fraction. And then what happens here is since the negative exponent is in the numerator, the entire term goes into the denominator. When something completely moves and there's nothing left, then the only thing that's left is in the numerator, which would be a 1. And then 5 to the positive power of 2 would be in the denominator. So this would be 1 over 5 squared. 5 squared is 5 times 5, which is 25. So this would be 1 over 25 in fraction form. Number 2, negative 3 to the 0 power. You might be confused whether this is going to be positive or negative 1, so you could always use your calculator to verify. Whenever you have whenever you have the parentheses around the negative numbers, it's always going to turn your answer into a positive. But if there were no parentheses, if it was just negative 3 to the 0, take a look. The answer is negative 1, so it's an odd thing. Negative 3 in parentheses to the power of 0 will be a positive 1. If the parentheses were not there, it would have been a negative 1. So this answer actually is positive 1. You can always use your calculator to just verify that. Number 3, the denominator has the negative exponent, which is not okay. So what we need to do to simplify that is take that entire term that has the negative exponent and bring it to the numerator. So it turns into 4 to the power of 3. And that would just be the final answer here for that in exponential form like that. Or you could simplify 4 times 4 times 4. That would be 64. And then 2/3 to the power of negative 1. There's 2 ways to solve this problem. One way we can solve this by using the quotient to a power rule and give the 2 the power of negative 1 and the 3 the power of negative 1. Then we can simplify that from there. Both of these numbers have negative exponents, so both of them need to move from their current location. The 2 to the negative 1 will go to the denominator and become 2 to the positive 1 in the denominator, and 3 to the negative 1 will go to the numerator and turn into 3 to the positive 1. So basically everything's going to switch locations, and then everything will get the positive version of the exponent. That's what the exponent rule tells you to do. Whenever you have a negative exponent, you just flip it from where it currently is. From the numerator, it will go to the denominator, or if it's in the denominator, it goes to the numerator. The second way to solve this problem is from the very beginning. This says 2/3 all to the negative 1. If you understand the idea of negative exponents actually flip things upside down. So this is the same thing as 3 over 2 to the positive 1. Which is just 3 over 2. So the final answer could look like this. You could just leave it like this, 3 over 2, because we don't necessarily need the exponents anymore. All right, and then example 4 is when things are going to start to get really crazy. So we're going to rewrite all of these expressions using only positive exponents, and they start out kind of easy, and then they start to get nuts. So whenever we have a situation that requires us to simplify exponents that are negative, we have to understand that when we have a negative exponent, this negative 3 here is only attached to the y. The 3 in front of it is not attached to it. It's like 3 times y to the negative 3rd power. So when we do simplify this, the 3 is not attached to the y at all. The negative 3 is attached to the y. That's its negative exponent. So what happens here is we have an invisible fraction, and this part of the numerator needs to move, only that part. The 3 will stay exactly where it's at, but this needs to come down to the denominator, and it will then turn into a positive exponent. So when I do that, I'm left with 3 in the numerator and y to the positive 3, will end up in the denominator, and then that would be your final answer. The final answer for that is 3 over y to the third power. I only moved the y to the negative 3 because that was the only thing that had the negative exponent. The 3 is not attached. However, when I look at this next example, 4x to the negative third power, there's more than one way to solve this. I could solve this by first using the power rule by distributing a negative 3 to the 4 and a negative 3 to the x. When I do that, this turns into 4 to the negative third power and x to the negative third power. This looks different than the first one because both of these numbers have the negative exponent right now, so both of these need to move. And it's not currently in fraction form, so I can kind of show you what it would look like in fraction form by making it into a fraction, by putting it over 1. And because both of these have a negative exponent of negative 3, they both will move to the denominator. So this and that will move down here. When that happens, the only thing that's left in the numerator is basically nothing. It's just 1 because this is a fraction. It's not like 0. Whenever you take something away, it's just going to be a 1 left over. And then this turns into 4 to the third power over x to the third power like that. Now, the only thing you could do to simplify this a little bit further is do 4 times 4 times 4. So you could simplify this to be 64x to the third. And we don't have any negative exponents, so that's fully simplified. And we also don't have any additional x's or anything that could be simplified using a different rule, so that would be it. In letter C, a lot of times students think that when you have negative exponents, the entire fraction flips upside down, but that's not the case. This 3 right here is totally fine being in the numerator. There's nothing wrong with that. It's just a 3 in the numerator. The only thing that is a problem is this right here in the denominator. So when we go to simplify this, the 3 stays, but this is going to move up top. So when that does move up top, the fraction actually completely goes away, since the x to the negative 2 will be raised to the top as x to the positive 2, and that would be your final answer for that one. Yes?
Say that like 3 was on the bottom and the x negative, would the 3 stay on the bottom too?
If the 3, if it was like...
Just like the other way around.
Like that?
I was thinking like 3 on the bottom and then x minus 2 on the top.
Okay. So if this was the question here, x to the negative 2 on the top and 3 on the bottom, the 3 would stay put. The only thing that would move is this. So that answer would be 1. Yes, it's like the same thing. The only time things move is if they have the actual negative exponent. All right, moving down the line, letter D, I have in parentheses 5 times s to the 5th times t to the negative 5th, all being multiplied by negative 6, s to the negative 2, t to the 4th. So looking at these problems, the first thing you have to identify is if there are any power rules, because those have to be done first, meaning that there's additional powers on the outside of the parentheses, and there aren't any. So I can just begin solving this. I'm just going to clear and scroll down so I have a little bit more space. So sometimes all these extra parentheses are really not that helpful. So sometimes I like to just, if I don't need them, I will just rewrite this as using multiplication signs, or if I need to, just so I can not be confused with all of the extra parentheses that aren't needed. And then, you don't have to do that at all, but that's just helpful for me. And then the next thing I want to do is look for my coefficient numbers. That's like the 5 and the 6, or sorry, negative 6. And then I can multiply those and get those out of the way. 5 times negative 6 is negative 30, so I can combine those through multiplication and be done with that. And then if it's helpful for you, you can like kind of cross them off. If you don't want to see them anymore, you can circle certain things. I mean, however you want to show your work to get to your final answer is fine. Or if you can just kind of do it in your head and not have to worry about it that much, that's fine too. The next thing I have is s to the 5th and s to the negative 2. Whenever you're simplifying exponents, you're only going to want to see one of the same variables, Because I have two s's in this in two separate spots, I know that I can simplify these because they have the same exact base. Here's when things get tricky. This rule is one of the first rules we learned. S to the fifth, I know it's not right next to it, but s to the fifth is being multiplied by s to the negative 2. When you have the same exact base numbers, you add the exponents to combine them all together in 1. So s to the fifth power and s to the negative 2 power can be combined by doing 5 plus negative 2. I know that's a little bit weird, but 5 plus negative 2 is 3. So this can simplify to be s to the third power altogether. So even though that negative 2 is a negative exponent and we know that we would move things around, you don't have to. You can solve it that way. You don't have to. You could just use the product rule and add them together, and then you're left with a positive number, which is good. But then when we go to the next one, the t's, that's not going to happen. I have here t to the negative fifth and t to the fourth power. So when I go to simplify this one through the product rule, t to the negative fifth power times t to the fourth power, again, since they have the same exact base, I can add the exponents, but when I add negative 5 plus 4, I'm left with a negative 1, which means that this answer is not fully simplified. Your answer will never have negative exponents in it, so because there's a negative exponent here, we have to then further simplify this. This is not okay. Only this is not okay. The negative 30 is fine because negative actual numbers are okay. Negative exponents are not. And the s to the third power is okay. But the t to the negative 1 power will go into the denominator as t to the positive first power. You don't need to put the power of 1 up there because I know it's there, so you could write it like that, or you could just drop that 1 and write negative 30 s to the third power over t, like that. Both of these are fine. You do have to write up negative 1 exponent because that's important, but when it's just a positive 1, you can drop it. All right, letter E says 2 times y to the negative first power times z to the negative third power over 4yz to the negative third power. So there's a lot of different ways that we can solve these problems. Using the quotient rule, I think, would be the best way to go about this, and then we can simplify using the negative exponents last. So I know I always said the first thing we should do before actually completing that is look for the coefficient numbers, I mean the 2 and the 4. So I can simplify 2/4 by dividing both of these numbers by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So I can simplify this whole thing by just making this fraction smaller. You can leave the 1 there or you can drop it. But if you do leave it there, that's fine. It will look like this. 1 times y to the negative 1, z to the negative 3, and then 2 on the bottom, which is y times z to the negative 3. The next thing we can do is use the quotient rule, which says if you are dividing numbers that have the same base, like this here, you can take the exponents and subtract them. So this is y to the negative first power, and this one is y to the first power. It's very important that when you do the subtraction, you start with the numerator number and subtract the denominator number. So this is going to be y to the negative 1, y to the 1, so we will have to do negative 1 minus 1 more. That's going to be y to the negative 2. So everyone bear with me, this is going to get really confusing. So altogether, this equals negative 2, which means that this is going to be y to the negative 2 power. When you have this and you have a quotient and you have the solution to the quotient rule, that y to the negative 2 power ends up in the numerator. So you have to put it back in the numerator. It's not going to stay there forever, but it's going to be there for now. And then the same thing's going to happen with the z's. So I have here z to the negative third power over z to the negative third power. I can use the quotient rule because the bases are the same, and I will do negative 3 minus negative 3. Well, negative 3 minus negative 3 is really negative 3 plus 3, which is 0. So what's weird about this one is this will then mean that the new exponent for the z is 0. So then I could put z to the 0 here. And then we're going to simplify this further. So to simplify this, there's two things that we should do. First thing is the y to the negative 2 power is not simplified since you can't have negative exponents. So what you will do is bring this, just this term down to the bottom. And then z to the 0 really equals what? Anything to the 0 power equals what? 1. So it essentially just is going to cancel out and go away. So the y to the negative 2 is going to end up in the denominator. The 2 is already there down there in the denominator. It's going to be y to the second power here. The z to the 0 just equals 1. 1 times 1 is 1. So this final answer is going to be 1 over 2 times y squared. This stuff is no joke. Okay, one more problem for today and we'll call it a day. So the last one, letter F, is asking us to simplify this whole thing. The whole thing has right now a power rule and it's raised to the negative 1 power. There's two ways to do this. You can either take each little exponent and multiply them all by negative 1 and then we'll have to simplify it from there. Or whenever you take a fraction and you raise it to a negative, it flips the fraction upside down, and then all of those things get that new exponent. But I'm going to show you just the power rule, which means I take all of these exponents, and I'm going to give all of them a negative 1. So what I do here is I multiply each exponent that it currently has by negative 1. So that turns into 5 squared. The 5 to the power of 2 is going to be times negative 1. The x to the 3 needs to be multiplied by negative 1, and the y to the negative 3 needs to be multiplied by negative 1. Everything in the denominator as well. This is 125. This needs to get a power of negative 1. The x needs a power of negative 1, and the y needs a power of negative 1. So whenever you have a power rule, every single thing in the fraction, in the numerator and in the denominator needs to get the new power. Whatever power it currently has, you just multiply it by negative 1. Everything in the denominator had an invisible power of 1, which is why they all then just turn to negative 1, since 1 times negative 1 is negative 1. Okay, so to simplify this further, 5 to the power of 2 times negative 1 is going to be 5 to the negative 2 times x to the negative 3 times y to the negative 3 times negative 1 is positive 3, all over 125 to the negative 1, x to the negative 1, y to the negative 1. All right, now I'm going to try and simplify things that I can simplify. This is crazy. 5 to the negative 2 is really going to go into the denominator and turn into 5 squared in the denominator, and 125 is going to go in the numerator and turn into 125 to the first power in the numerator. So these are going to switch. This is going to turn into 5 squared down here. This is going to turn into 125 to the first power up here. And then 125 and 5 squared we can then simplify in the end as well. And then for the x's, x to the negative 3 and x to the negative 1. Negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. So then when I simplify the x's here, this is going to be x to the negative 2 at the top. And then for the y's, it's going to be 3 minus negative 1, which is really 3 plus 1, which is 4. This is going to be y to the 4th power. Everyone with me? Okay, two things we can do here. We should simplify the coefficient numbers. 125 divided by 5 squared simplifies to be 5. So 5 here. X to the negative 2 will go to the denominator, and y to the 4th will stay in the numerator. So this final answer will be 5 times y to the 4th power over x squared. Oh my gosh, that's crazy. So I know it's been a long time since you saw exponents, and now all of a sudden we're doing like crazy stuff like this. But with practice, it will get easier, I promise. So we are going to call it a day. I think that you're ready for that.